today's lesson is 17.2, transformations of sine and cosine graphs. So today's lesson, there is a assignment with it, and that will be extra credit if you read that in your Google Classroom. So go ahead, take notes to help you on getting through that assignment for extra credit. So our general forms for our sine and cosine graphs would be y equals c plus a times sine of b times the quantity x minus d. And then the same thing for cosine would be y equals c plus a times cosine of b times the quantity x minus d. All right, where your a, your b, your c, and your d mean something in terms of how the graph is changing from just the basic sine and cosine graphs that we have been working on. All right, so kind of thinking back to Algebra 2, when you had transformations of graphs, things that move the graph up and down, left and right, stretches, compressions, reflections, that still kind of happens here too. So the C for both of those will move your graph up C units, and we go down if it said minus C. So plus C goes up, minus C goes down that many units. Same thing for either cosine or sine. A, as we've already looked at before, is your amplitude, so that hasn't changed. We talked about that already. B, if you recall, helps you determine the period by taking 2 pi and dividing by b. And then here, D is going to move it right if it's minus D, left if it's plus D, and we call that a phase shift. So you'll see that term being used in your homework. Okay. We may see problems where the B will be distributed in here. All right, so we'll still see that same B, but we must factor the B out to know the proper phase shift for D. So we'll look at a couple examples where that occurs. All right, so just knowing that general form, we'll get started here. Our first examples, I want you to find a number of things. I want you to find the amplitude, the period, translations, and the phase shift. Okay, so the translations will be an up and down. The phase shift will be your left and right. And then the amplitude and period we've already done before. Okay, so for our first example here, my equation is y equals 5 times cosine of 2 times the quantity x minus pi over 3. Okay, first thing, let's find the amplitude. So the amplitude, remember, is always the number that is out multiplying in front of your trig function. So 5 is my amplitude. Next, if we find the period, I must take 2 pi and divide by the b value. So if there is a number out in front of those parentheses and you just have a 1 in front of the x inside, that's going to be your b. So 2 pi divided by 2 would mean the period would be pi. Next, the translations. Would be there has to be a number adding or subtract, or a number out in front, whether it's positive or negative. There is no number out in front, or it would have to be off to the side over here. So technically that would be 0. So there are no translations. Your phase shift since our B is factored out, I just take a look right here. So the minus means I'm going to move right, kind of like we did in Algebra 2 with quadratics. It's the opposite sign. When you had problems like, if you remember doing things like x plus 3 squared minus 4, where that means I moved left 3, down 4. It's the same exact concept as that. So my phase shift will be right pi over 3. All right, so you have problems we'll ask you for each of those things, and then you're filling in those blanks for all of those items. So we're going to practice a few more of these to get familiar with the form and what all those numbers would do. So y equals -1 plus sine of, in parentheses, 4x minus pi. All right, so my amplitude would be the number that is multiplying in front of my trig function sine. So that would be 1, if nothing's listed. Next, the period. I need to take 2 pi and divide by b. There is no number put out here, so I need to look at the number next to x, which is 4. So I'll take 2 pi and divide by 4, since that is my b. So pi over 2 would be my period. Now this time I will have translations. This number out here in front is a translation. Since it's -1, that means I'm moving the graph down 1. We'll look at what that means for a graph when we practice graphing a few of these. But then my phase shift this time, since the b is inside of the parentheses, I must factor the 4 to the outside. So then I just have an x because I divided that 4x by 4. But now I need to take that minus pi and divide it by 4, since I factored the 4 out. Okay, so this minus pi is not my phase shift. The minus pi over 4 is my phase shift. So that minus means I move right, pi over 4. Okay, we'll look at a couple more. This is kind of the main thing, is to get what's happening with all these things. All right, so y equals 6 minus 4 cosine of 2 pi plus pi over 2. All right, amplitude is 4, the number multiplying cosine. Now there's a negative, but that negative is going to be a reflection. It is not your amplitude. The amplitude must be a distance, so it is always positive, remember. All right, next for the period, I'll take 2 pi and divide by, my b is 2, so pi would be the period. Next for translations, I've got the 6 out here. It is a positive 6. The negative goes with the 4, so I'm moving this graph up 6 for the translations. All right, then for the phase shift, so I'm just not writing down these things anymore. The phase shift, I must look at this number, but since the 2 is not factored out, I am not adding pi over 2. I must factor the 2 out. So divide each of those by 2, which would give me pi over 4. Okay? Pi over 2 divided by 2 is the same as pi over 2 times 1 over 2. So I'm multiplying my denominator by 2 to get pi over 4. So the plus would move it left, and then pi over 4 be the number that I'm moving. Okay? Last one we'll take a look at here, and then we'll practice a few graphs. So y equals -4 plus 2 sine of 5x plus 3. Okay? All right, so my amplitude, number multiplying in front of sine and cosine, would be 2. The period, take 2 pi, divide by 5 would be my b. So 2 pi over 5 would be the period. The translation, so I have a -4. So I will be moving this down 4. If that was written over here, that would mean the same exact thing. All right. This book oftentimes writes that out in front. I've worked with some of the trigonometry books that we have for our elective, and then that usually writes it off to the right. So you can see it either way. All right, then my phase shift happens with inside my parentheses here. Once again, I must factor the b out. So then I'm dividing each by 5. So then my phase shift is left 3/5. So it's possible you won't have pi in there. Okay? All right. So that's just kind of the little details. You'll have to fill in those things in the homework, and then you'll have to match graphs. You're not going to have to actually physically graph in the program. You'll have to match them, or you'll look at an equation and have to, or you look at a graph and have to write the equation. All right, but we're going to practice a few graphs by hand. Okay, so my first one, y equals 2 plus 2 cosine x. All right, I always like to write a little bit of information, like my amplitude is 2. This plus 2 means I'm going to go up 2. The period for this one, there is no extra number here, so my period is just the typical 2 pi. Okay. So generally the ones that I've looked at that you have to match sometimes have a full period, sometimes 2 periods. All right. So what I end up doing with this plus 2, okay, is now instead of kind of everything coming back to the x-axis, and that's kind of like the center of your graph, now the new center of my graph is positive 2. So that's where I'm going to come back to. So I like to make a little dashed line to remind me to come back to that. So the amplitude is how far away I am from what this is called the sinusoidal axis. Not that that's important, but how far I am away from that instead of how far I'm away from the x-axis. So I'm going to be going 2 above and 2 below. So my graph is going to fall as low as the x-axis and as high as positive 4. So it's all going to kind of make its little wave between those 2 red dashed lines. All right, so if I'm dealing with cosine, that means I start, in this case, 2 above, since my amplitude is 2, I start 2 above the center of my graph when I'm looking at 0. So it starts here. Okay, I'll go ahead and fill in my scale. So that's pi over 2, pi, 3 pi over 2, and 2 pi, since my period is just 2 pi. All right, so then at my next point, pi over 2, I come back to the center, and then to the bottom, back and up, to represent cosine when I have an amplitude change isn't anything different, but this graph has been moved up 2 units from where it normally would be. Right, I could do the same on the other side if I wanted to, but you're mostly just going to be matching these graphs. Okay, so if we just get that general visual, we're good. Let's try another one. So y equals sine of x minus pi. Okay, so here my amplitude would be 1. 1 would be the b, so the period is 2 pi. I do have a phase shift. I'm going to move this right pi. So we'll kind of see what happens when we have a phase shift. All right, no movement up or down like in our last problem. So everything's going to be kind of centered around the x-axis in this case. All right, so the highest it's going to go would be a positive 1. The lowest it's going to go is a negative 1, because that's the amplitude, the distance from the center of my graph, which is the x-axis. Okay, the period's 2 pi. So I can go pi over 2, pi, 3 pi over 2, 2 pi. But something I want you to notice that's a little bit different now. With a phase shift, where I start is going to be, I got to go right pi. So sine would start at 0. So now I'm beginning here. instead of at 0, 0, because I had to move this graph right. And then sine goes up, back, and then we go down again over here. I can either create another point as 5 pi over 2, or I can go backwards, right? So I was down, back to the center, up, back to the center, down, back to the center for 0, 0. So I've completed a full period here. I could keep continuing to go backwards, depending on how far I need to go, but you're just going to have to match that in the general direction. Okay, we'll do one more graph. So y equals 3 cosine of 1/2 x plus pi, and then minus 1. Okay, so a lot going on with this one. I've got an amplitude of 3. I will have a period change this time, so 2 pi divided by 1/2 would be the same as taking 2 pi divided by 1/2 would be multiplying by 2. So 4 pi is going to be the period. I'm also going to move this down 1. I need to factor out the 1/2 to figure out my phase shift. So that means I'm dividing pi by 1/2, which means I'm multiplying it by 2. So I'm going left 2 pi. All right, so a lot going on. Let's kind of get our picture of our graph going. All right, so I have this graph moved down 1. All right, that is going to be the center for my graph. I have an amplitude of 3, so that means the highest I will go is 3 above that line, which would be at positive 2, and then 3 below that line, so at negative 4. So I'm coming back, or I'm staying in between those red dashed lines. Okay. All right, so then I have a period of 4 pi. So if I cut that into fourths, I am going by pi, 2 pi, 3 pi, 4 pi, negative pi, negative 2 pi, negative 3 pi, negative 4 pi. I might not need all of those on there, but just to kind of see that. So if I'm going left 2 pi, that's going to be kind of a starting location for me. So right here, negative 2 pi, I need to pay attention to this is for cosine. So cosine would not start on this new green axis that I've created for moving down 1. Cosine would start basically at its amplitude, which is 3. So I would start up here at the highest level, which would be a y-coordinate of 2. All right, there's no reflection here, so then cosine would go down. I might change my color. I'm going to do blue. So it's up here, then it comes back to the axis. We'll go all the way down as low as it goes. Next at pi, we'd be back on the axis. Then at 2 pi, we'd be back up. All right, for a 1 period of cosine. All right, that should hopefully make sense. The period's 4 pi, so we have to complete one round here of cosine within 4 pi. So if I travel from negative 2 pi to 2 pi, that's a distance of 4 pi, right? 2 pi from negative 2 to 0, and then from 0 to 2 pi would be another 2 pi. Okay, you can obviously keep going more points, but you could at least get enough to match your graph from there. All right, good luck. Finish as much of the homework as you feel you want or need to get a few extra points here ending out our course. Thanks, goodbye.